to write down the domain on 5.5, which we just did 5.4. Write down the domain of the inverse. So if you look at the domain, you're actually looking at the x values where this graph actually exists. So let me just go up a bit so that you can see this graph. So you can see this graph is actually, the asymptote is y equals to 0. So the domain of this graph is just from here going to infinity. So we can say if we want to find a domain, your x must be greater than 0. As long as x is positive, it's on the positive side, x cannot be 0 because that's an asymptote. So x must be greater than 0 because our asymptote is now at x equals to 0 instead of y equals to 0 now, because that's the inverse. X changed into y became x. So yeah, you need to also understand what is the domain. And the other way of doing it, somebody can say the domain, let's say the range. Let me just say the range of the original function was actually of h of x. The range was that y is an element of, and your y was actually greater than 0 because it was on the positive side. If you take a look at the original graph, so it was actually at here. The graph was from going up, so y was greater than 0. So since what we said, when we have an inverse, your y change becomes your x, and your x becomes your y. So it means if you have an inverse of a function, the range of the original function will now be the domain of your inverse. So our domain will simply be this keeps fixing itself. Let me erase this. So our domain well, now, because domain is always y value, so it's always x value, so x will be x must be greater than 0. So anyway, whether you interpret your graph because your graph will be correct, or whether you take it from the range, knowing that your range becomes your domain and your domain becomes your range, because everything swap when you're actually finding the inverse. I hope that makes sense, and if it doesn't make sense, I can also prepare a lesson for that for anybody who would like to have such lessons. And hence, otherwise, determine the value of x for which the log 2x is actually greater than 1. So in actual fact, remember we found our logarithm to our inverse to be equals to y is equals to log 2 of x. That's what we found. That's what we got. And let's go up and look at that structure diagram that we had. This is our diagram, and you can see, let me just erase so that people don't get confused with this. Let me just try to erase some of the parts that are not important for this question. Good. So things can be a bit clean this side. I think it will be easier if we look at it from here. Since we have space, we're looking for where y is greater than 1. Which y? The y of the inverse. So I'm going to just focus on this because this is the same as your log base 2x, right? And then I want it to be greater than 1. And knowing very well that if I have a log with base 2, and x equals to 2, it will give me 1. The log of a number and having that number being equals to the base will actually give me 1. Even if I have a log of 100 with a base of 100, which actually gives me 1. So I know if I want it to be greater than 1, as soon as it's equals, when x equals to 2, my log will actually be equals to 1. So when x equals to 2, if x equals to 2 this side, my y value will actually be 1. And if I want your log 2 of x to be greater than 1, so it means that as we go up, all the values will be greater than 1. So x must be greater than 2. As long as x is greater than 2, then I know that my log will always be greater than 1. I hope that also makes sense. You can also interpret it graphically. It will also make sense, but we can also check that mathematically using the laws of logs to see that my minimum value to get 1 is actually when x equals to 2. I hope that also makes sense.